So this is the next question that we are going to solve. A disc of 5 kg with radius of gyration 60 mm is mounted centrally on a. The importance of centrally is because to find if the weight of the shaft is also given, then the thing is, if the disc is not centrally at center of this shaft, then at, at the length center I'm talking about, and actually it should be at the center, means this plane center it should be, but also it should be in length center, otherwise the disc will produce a different gyroscopic couple in the same direction, shaft will produce a different gyroscopic couple but in the same direction, so that will create a problem. 100 mm between the bearings. It spins about the axle at 800 rpm counterclockwise when viewed from the right hand side bearing. The axle processes about a vertical axis clockwise direction when viewed from above. Determine the resultant reaction at each bearing due to mass and gyroscopic effect. The resultant reaction of at each bearing means a reaction by the bearing. What reaction does the bearing provide? So this is the same question that we did before. The thing is, it is counterclockwise when viewed from the right hand side beginning bearing. So this is suppose right hand side from here. This is counterclockwise. So this side. The L should be from here counterclockwise, and that too using right hand. From here, if we see towards me, yeah. So I don't know how he wrote this, but in my equation, as I have seen from right hand side being, if I'm seeing this is a counterclockwise and L is in this direction, so L is in this direction. Now from above clockwise it rotates, so free from seen from above clockwise it rotates means this is a circle, clockwise means this side here is to rotate, so this is delta L. So here it will be action torque, this will be reaction torque. So if this side is a reaction torque, that means this the gyroscope effect will produce a downward effect on this bearing, an upward effect on this bearing. So here minus will be happen, here total addition will be happen. Now as I did before, reaction bearing due to gyroscopic couple is equal to gyroscopic couple divided by length, just like simply supported beam. At simply supported beam at center there is a couple of I omega omega p. I mk square omega omega p. Divide Ra into L minus this is equal to 0. So you get value of not Ra. I'm not talking about Ra due to reaction due to gyroscopic couple I am talking. So this thing you will get reaction given by the bearing. Yes, we have to find the reaction given by the bearing. So this is the solution I did, and if you have any problem then you can just see here. So this is the second question. A uniform disc having a mass of 10 kg, uniform means a solid disc of mass 10 kg in radius of gyration 160 mm is mounted on one end of a horizontal arm of 200 mm length. So it's just like a cycle tire, the cycle tire that we rotated in the experiments. The other end of the arm can freely rotate in universal bearing. The disc is given a clockwise spin of 250 rpm as seen from the disc end of the arm. Disc end of the arm means the end where the disc is located. From view from there, determine the motion of the disc if the arm remains horizontal. Arm remains horizontal, that means why would arm remain horizontal if there is a gravity? If there is a gravity, then the arm should fall. No, it is not falling because gyroscopic couple is opposing it. So what is the value of the gyroscopic couple which is opposing it? Is I omega omega p. I omega omega p. So this is the figure. So I omega omega p opposes mgl. I is mk square into 2 pi into 250 by 16 to omega p. You will get the value of mgl. Omega p is equal to 2.9289 radian per second. But in which direction it is rotating? So for finding the direction, you have to see is clockwise spin from the disc end of the arm. From here, clockwise, it is clockwise, so L is this direction. L is in this direction. L is in this direction. Horizontal means this, along this L. Now if L is in that direction, and what is saying, so you, what do you need? You need a couple which opposes. This couple is due to mg into L is in this direction, means clockwise, so you need an anti-clockwise couple. So suppose if we go this way, suppose if the disc goes this way, means this way means clockwise, and this is delta L, so reaction torque will be this direction. So this direction means, so from the center, if you take our hand and poses it this direction, this is forcing this to go down, but we don't need that, we need an upward. So हमें चाहिए ऐसा, यहाँ से देखो, हाथ को ऐसे करो, here upside means इस डायरेक्शन का रिएक्टिव चाहिए, इस डायरेक्शन में रिएक्टिव चाहिए, इस डायरेक्शन में रिएक्टिव चाहिए, तो इस L को इधर जाना पड़ेगा, इधर जाना पड़ेगा, मतलब what is this? First of all, this has to go here, means shaft has to go, this is the shaft has to go here. I think you have not understood what I'm trying to explain. This is the shaft, L is here, you need a reactive torque here, so action torque with this direction means this direction you need L new. L new is this direction, means this has to go here or this has to go here. What is this motion? This is clockwise, so the rod has to shaft has to rotate, shaft will rotate clockwise to counter the clockwise as seen from the top. Disc should rotate clockwise. So yeah, this is I verified. So this is the third question. Determine the gyroscopic couple of a 3-meter diameter solid aluminum alloy 4-bladed propeller in which each blade has a mass of 20 kg. This means there is a fan which has 4 blades, each blade weighing 20 kg. The test of the aeroplane is a power on flat spin in which the propeller speed is 1500 rpm and the rotation of the flat spin is 1 radian per second. The radius of gyration of the propeller with respect to the propeller axis is approximately half of the propeller radius. Determine the gyroscopic couple. So you have to determine just the value of the gyroscopic couple. So what is the value of the gyroscopic couple? Is I omega omega p. And what does the I represent? I represents polar moment of inertia of the disc, because about the polar means about which it is rotating, and torsion mein why we use polar, because about that axis it rotates. Number of propellers force, mass of each propeller 20 kg, mass of whole propeller 80 kg. The radius of gyration of a propeller with respect to propeller axis. Gyration with respect to propeller axis, that's necessary because the propeller axis is this axis, z axis, and about this center of gyration, about this means from here the center of gyration is calculated. So this is what we need to find, to use the value mk square. Given that k with respect to propeller axis is propeller radius by 2, 3 is the diameter by 2 by 2.75 meter. So polar moment of inertia is equal to mass moment of inertia about propeller axis is equal to mk square, which comes out to 45 kg meter square. This is the standard unit. Gyroscopic couple is equal to I omega omega p. I 45, omega 2 pi into 1500 by 60. It just gave something. Flat spin, rotation of the flat spin is 1 radian per second, so it must be So suppose this is a airplane. Suppose this is a propeller. About which axis it will turn? So this is the this is the axis of spin, and it turns about this axis. So I have one axis which is in direction of thumb. So this is the precision axis, whose omega p is 1 radian per second. So you get the value of 7065 Newton meter.